Nice. Yeah, so hello everyone. My name is Erik. Um, so the title of this presentation is Craft and Perception. And as Moises said already, like we are a relatively young practice outside the US, and I will just want to give you a bit of an insight on how we work with bio-based materials, like looking at mainly two projects and two different scales that you can see here. And mainly to give you a bit of a background, so our practice is in Switzerland. It's a relatively small country in the center of Europe, though not part of the EU. And I'm showing this to also, give you a sense of geography and climate. I think our climate in Switzerland is relatively similar to the one in New Jersey. I think your winters and summers are slightly more extreme, but not too different. Also, I was just researching just before the population of New Jersey state and Switzerland is basically the same, more or less 9 million inhabitants each. So we're not all too different. I'm running this practice together with my partner, Remy Chaudin. We met each other around 10 years ago during our studies at ETH in Zurich. And he's like he's become an expert in earth construction. And he also gained a lot of experience on construction sites. So this photo shows an example of a ramped earth wall that we built together. And here another example of an ramped earth oven that we built. He's also very much interested in kind of sharing knowledge and having construction sites where kind of people can join and learn. And as Moises said already, after the ETH, I went to the GSD for my master's, and there I developed my interest in kind of adapting existing structures and modifying buildings and also kind of playing with the perception. And this model was part of my thesis, where I've introduced a new bracing system to the existing tower in Berlin, allowing to remove the existing cores to free up the plan and introduce new functions. So there's been kind of a pragmatic approach, but at the same time, it drastically altered the urbanistic perception of how the building is read in relation to the ground. Anyways, and then also just to mention that we are both working part-time at ETH, Remy mainly in research, and I'm mainly teaching, because we think it's always very fruitful to have an exchange with students and just, testing new ideas. And this was part of a Earth workshop that Remy organized. Now, we are based not in the city, but outside the city. You can see here at the tip of this Zurich Lake, that's the city of Zurich. That's also where we live and partially work. But the office is really outside. One reason being that, like outside the city, it's much easier to get in touch with craftsmen and kind of building a network a little bit, independent from the fierce competition inside the city. And so one topic that we both think is very important is to move the building industry in a so-called right tech direction. And what we mean by that is we are kind of criticizing the amount of technical systems and equipment that are built in buildings, especially over the past decades. It has really steadily increased a lot, and we don't think that it has improved the 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 inside climate much, and also these systems, they are quickly outdated, so it's not very economical. And we think there's a lot of knowledge if we go back in time, even into pre-industrial times, where the construction itself had a lot of kind of knowledge that has then eventually were taken over by technical equipments. And so there are two terms, one of which is thermal mass, and the other one, vapor open construction, that I want to talk about more in a second. But then at the same time, we don't want to be like only low tech and no high tech, but we think instead of putting the tech inside the buildings, we want to leverage it by, using it in an efficient planning process and doing, for instance, thermal and vapor simulations. This is the first project I wanted to share with you. It's a private house extension. You can see the existing house on the photo on the right and the lower part of the model. And so in this house, a grandmother is living, and the request from the client was that she can live together with the family of the granddaughter. So the project would turn into some kind of multi-generation house. And that's why we proposed to add this new story where we can offer more area. And we really like the idea that it's really like a new bar just sitting independent on top of the existing house. Also, the cantilever on both sides exemplify it, which was possible due to the building code to kind of move closer to the plot line. And also the topic of flexibility, that the new extension works independently from the existing house by introducing this exterior staircase while introducing also a shared terrace that can be used by both. Now, talking about our goal for this building to reduce building equipment and incorporating certain system in the construction itself, I want to use this slide to explain a bit about the topic of thermal mass. And so you can see in this space here, we have this big opening facing the south. And when it's wintertime, no, sorry, when it's summertime and the sun is high, we kind of extended the roof so that the heat is blocked and is not overheating the interior space. In contrast to the wintertime when the sun is low, it can enter the space. Also, based on the simulation here, we could kind of see in which area the sun would hit. And for that reason, we materialized the floor here differently by using, for instance, a rammed earth floor or just using stone tiles, a material which kind of absorb the heat and then slowly release it during the cold winter time. And this, as a result, allows us to not have any heating in this main space, but just punctual heating in some of the other rooms. In order to do so, it's also important to have very good insulation. So you can see it here in the section. The insulation we use is quite thick. It's 40 to 50 centimeters. I guess that's a bit less than 2 feet or something. And we are using materials such as sheep wool in the roof and hay in the gable facades. And since the title of the presentation is Craft and Perception, here I just want to point out, oftentimes insulation is like a material we never see. It's it's in the facade, it's cladded from the inside and outside, so you never really know what is inside. And here we are playing with the idea to showcase the characteristics of the soft sheep wool, and therefore we've cladded basically the inside of the roof with a textile so that the sheep wool can kind of pressure against it and give this cushion feeling on the interior. Then the other topic was the vapor open construction. And so typically inside the building, moisture is building up because humans are sweating, we're cooking, we're showering, and so on, and therefore the vapor needs to somehow leave the house. And in today's building industry, I think that's the case both for the US but also in Europe. We typically make an airtight facade where the vapor is sort of trapped, and then we add additional mechanisms such as ventilation to bring the moisturous air outside and to bring fresh air back in. But that was not the case, let's say 100 years ago. There, the facade was built in such a way that the moisture could travel by itself through the facade and kind of leave the house. And this is something we're also trying to implement in this house. For that, as you can see here on the screenshot, we're doing some kind of simulation to see what materials to use so that it can travel freely without condensating within the construction system. I can talk about this maybe a bit more in detail later. Yes. And I mean, here again, this is also something we're trying to do in order to then not use additional technical equipment to do this whole thing, but the construction itself is really doing it. Now, this is the second project I wanted to show, also kind of to contrast to this private, very custom building. This was a big school competition, so the scale is much bigger. Here, the volume is very straightforward. It's a box with a courtyard. And the reason for the box is to have a minimal envelope area, to have minimal energy loss. And here, topics of modularity and also thinking of life cycles of different building components was very interesting to us. So as you can see here, we were saying the grid of the building, which are the columns and the beams are the most permanent elements, and therefore we materialize them in concrete. Also kind of precast elements to speed up construction time and so on. And then the secondary elements would be the floor plates that also take up actually the most mass and most weight in the building. And those we materialized in a timber earth composite. Again, here playing with the idea of thermal mass. And here the detail is also made in such a way that you can visually see that these elements are really just placed, placed with this very simple holding mechanism so that you can kind of imagine that in the future these might be disassembled or again or just modified. Then on this slide, I just want to make the point that we also we increasingly trying to use numbers and calculation to prove certain points. And in the submission, we made a calculation for one module to see how much embodied carbon is within the module, and then compare it against the conventional construction so that we kind of make the point this module has less than a third of the embodied carbon than what a conventional construction would have. And so I think this is also something we want to build out more to use like a data-driven approach to make a point and to convince potential clients. Okay, and so this would have already been the last slide for the presentation I made 2 weeks ago, which was at that point very much work in progress. This is a mock-up that we were planning for the house extension that I was showing you before. So here you can see it's the connection of the roof with the gable facade and the ground. And we were kind of telling the clients that it's quite important to build a mock-up, even if the scale is relatively small. In the scale 1:1 to really test all these materials because it's in a way experimental. Well, now that it's 2 weeks later, we already had the chance to build everything, and now I can show you. Here you can see some of the partition walls we were testing with some earth plaster and some hay. Here again, this is the gable facade, which is insulated with straw. This one is 50 centimeters, and then on the inside it's plastered with earth, and from the outside with lime plaster. And here on the roof, this testing with the textile and putting the sheep wool from top to make this effect similar to here. Maybe also to make the point for like we really like making things, also to have the exchange with different craftsmen before we actually build the building, because there's always very valuable lessons in what their opinion is or how would they detail certain things. So this exchange with craftsmen is something we are valuing a lot. And yeah, this is already the end. Thank you, and feel free to throw some questions at me if you have any.
Thank you. Such exciting work. Yeah, it's nice to see that little update in that physical model at the end.
Yeah,
I'm always pushing my students to build something, test it out, engage it, like see like what's working, see what isn't working. So I guess just to start off, how much
yeah.
of a role or how important do you feel that these mock-ups are for you? And then like you said, you want the roof to achieve a certain type of insulation property. So like how do you gauge or how do you test some of these things?
Yeah. So, I mean, we think it's really super important to build physically, ideally in the scale like 1 to 1 or as large as possible, because also here, I was drawing those plans and I was super convinced that the way I draw it, we would exactly build it. But obviously, like once you start building, it's not gonna work out 1 to 1 as planned.
Yeah.
And in that, you can already draw like very valuable lessons of, sometimes it's just very hard to connect certain pieces and you will only figure out once you actually do it.
Mm.
Um, in terms of like the build-ups and so on, I think if we have the point of we have a straw facade, we have a wool facade and so on, and using all these different layers, we really draw from the experience of other houses that were built. There are comparable building systems also used today, but especially back in the times. And so, we try to talk to people. We, are both architects and craftsmen and kind of get their feedback of their experience. And this is how we, collect a lot of data of, what is durable, what is working, what is not working. Um, but then, of course, this is kind of work in progress, but we are trying more and more getting into those simulations in order to verify with programs such as, simulating thermal mass or vapor open construction to verify it's actually working. And this is these are the two paths we are trying to follow.
Nice, nice. Um, what about the rest of the students? Do you have any questions? I know some of you have certain topics that some of his work may be touching on.
I'll just go through the slides. Maybe something will trigger something.
Yeah. You seen Carolina, insulation.
Hey, I was cutting off a little bit. I just had a question, like, what was the purpose of that slant roof over the wall?
You gotta help me. You talk about this one here?
No, I'm sorry. It's above the door right there. Did you have that testing?
Uh, on this slide or different slide?
Another slide where you guys were testing that like portion of like the door with that slant over the second angle above the door. That right there.
Here, this one.
Yes, that little angled thing above the door. What would that be?
Wait, so okay, this one, maybe I quickly go back. So to make this model, this is not a door, it's a window. And if I go back to this model, it's basically this part of the building here.
Oh,
Um,
I see it now.
yeah, so here, maybe yeah, it's a different topic of which I haven't touched upon, topic of reuse. So here, I'm not sure how to call it in English. I think it's something like knee facade, or this the portion of the facade below the roof.
Mm.
We're trying to fully glaze it basically with glazing because it's the north facade, just to get some more like lower light inside. And here we're testing to use reuse windows in different sizes and just collaging them in. That's why you have this a little bit funny rhythm going on here. And then now if I go back again to here to this one or this slide, I mean, it's not completely finished, but here we're just trying to test the structure of, the wooden beams going from the straight facade into the roof. Then we want to try to insert like a glazing here. We also potentially thinking of having, instead of using triple glazing, which is nowadays very common in Switzerland, to have like a double glazing outside on the exterior and then having another double or single glazing on the inside and having in between like a little greenhouse or something. Um, and yeah, besides, I mean, it's just like how to make the connection with this element and this element. Then here on the roof, we have the insulation inserted. Um, and it's been, yeah, just a test of how everything comes together, the assembly and so on.
Very cool. Thank you very much.
If you could, hi, my name is Yassine Abdelaziz. I thought the presentation was great. I think you did a great job, especially with the model as well. Whether it was the physical or kind of what you have going on over here. If you could go back to the smaller scale model, I'd love to see it again.
In this one, huh?
Yeah. So I think it was the previous slide that you just, yeah, perfect. So I actually at the architectural firm that I currently work at, we had an issue where we had a similar roof and the client wanted to add some balcony space. So we used these windows. I added it to the chat. I think it would be a great idea to look at that. I know that you specifically amplified on these windows, but these kind of windows open up into balconies and it creates really interesting spaces. And I think for a big roof like that, highlighting moments where you'd be able to walk out and kind of engage with Switzerland, because I know that you guys have great views over there instead of New Jersey. It would be pretty interesting to see if you could kind of amplify that.
Yeah, no, it's a great comment. Actually, so this is the north facade facing the street, so the, let's say, less interesting side. And then on this side, that's where we like try to introduce this rather big opening with, where you can fully open the glazing. But it's a good point. We have this regulation here in Switzerland that you can only do such a thing. I'm also not sure how to call it, but having this push out of the window being not larger than 1/3 of the width of the entire roof. So measuring from here to the very end, and then you can take 1/3 and do such a build-up.
Okay, I see. Thank you.
What about Mariam,
Um,
Duani?
I was gonna ask, in one of the slides where you were presenting the fabricated model of like that window side, you had like this frame with like filled up frame, that one. Can you just touch up a little bit more on that? I don't think I really understood that. Like, what is that doing? Like insulation?
You mean the lower
The
part
one to
here?
the left,
Here, this one.
the picture before
Oh.
that.
In the straw field.
Yeah.
Oh, sorry. These ones here?
Yeah.
Yeah, so exactly. Um, yeah, so I mean, basically, this is the one where we tested the outside facade connections, and this other model was just to test the floor buildup as well as interior walls. Um, and if I go back here again, I mean, this was really like just a test, but we had this thing in mind where oftentimes you use in a construction a lot of layers, and we like to think of ways how to simplify everything. And so in this example here, we had kind of a formwork similar to what you would use with concrete, and then made this mix of earth and hay, and we kind of all rammed it inside. And this could be, it has enough mass that it could act as a normal interior wall in terms of acoustical properties and so on. Personally, I think it's like right now how it looks a bit too rough for a residential use, but it theoretically could work. And then this panel that you can see behind here. Maybe also go to the rendering for orientation. So this is kind of the main wall, and then on behind the wall we have 2 bedrooms, 1 bathroom, and they are also subdivided by interior walls. And so this inclined wall would be one of those. And there, I mean, we just used wooden studs and again sheep wool, and on one side we used the plastering or earth plastering, and then on the other side we tested again with the textile, and so these were just tests for interior walls.
So then compositionally, how much of your work, I guess, depends on, I guess, like the research that you have done and I guess like pre-existing ways to build, for example, a straw wall, a certain type of ceiling or rammed earth composition versus you trying to optimize for, I guess, like a very specific condition that happens on a site. So is there an interplay between the two, or do you just, I guess, sort of see what works and then see what can be applied?
Yeah, it's a tough question. I mean, I feel like it's not super site specific. It's more, let's say, climate specific, right? You could say all these systems, they could be applied in different areas in Switzerland, or like in actually like anywhere. Um, it's more maybe the immediate context of the building program that we say, okay, we need, it's residential, or we need certain acoustical properties or something like this, or it's higher up in the mountain, so we need more insulation. So these things might be drivers, how to think, how to adapt certain constructions. And I mean, I think since we started 1 year ago, so everything is really in the doing. I think we want to rely at the beginning now on pre-existing systems more, just to be, make sure everything is working. But of course, like eventually we want to push a little bit and just try, what is possible. I don't know if this fully answers the question.
Oh yeah. Um, so then on the business side, I know we discussed this a little bit, but I think it'll be nice for the students to hear. How do you, I guess, like reach out to clients, convince clients to use some of these strategies that you have, whether for part of their house or bigger portions of the house, being that they may require upkeep, may require maintenance, they may require, I guess, like certain specialized treatments so it doesn't rot, it doesn't decompose, or whatever the case may be.
Yeah. I guess the main two arguments are, first of all, if the construction is smart by, incorporating all these features, and you don't need additional technical equipment, you could argue in economic terms that your your maintenance cost will actually be much lower. So this is like definitely a convincing argument. Then the other one is using natural materials as such, instead of using materials that rely heavily on plastics or cement. You can also make the argument it's healthier to live in such an environment. But then, to be honest, like reaching out to clients or clients reaching out to us, they already have this, in mind, these topics. And I think in Switzerland, there's already a relatively big culture or awareness of these materials being good. So, we don't need to do too much convincing work. And yeah, I guess like the clients that work with us, they already have some, things in mind, and we can kind of clarify, but we don't need to talk against them or try to convince them so much, I guess.
Got it.
Yeah.
So then I have two questions, one for you and then one for the class. So the one for you would be, what does the maintenance look like for these walls, roofs, etc.? Is it low? Is it high? And do the residents enjoy partaking in any part of the upkeep and of these things? And then for the class, could any of you see yourselves or some of these strategies being used in New Jersey, New York? What do you all think?
Well, if I would start, it's hard to say. I mean, we think what we are building is quite durable. Maybe the image of it really doesn't give the feel, but we're trying to build that it works for a long time. Also, the aspect that I was talking about in the school competition, of detailing a building in such a way that they could be easily adapted, I think is quite important because there are always elements in the building that will last longer and some others that you might even want to replace or the program forces it to be replaced. And therefore, I think also smart planning allows for easy changeability. I think this is super important. Um, and besides, I mean, there are many examples of wood buildings, earth buildings, and so on here in Europe that are standing for hundreds of years, which is much longer than like modern buildings. So I think in terms of maintenance, I'm quite confident that these could be durable buildings.
Yeah, I think it could work. Kind of like Eric said and Eric mentioned, the climate, from what I'm understanding in Switzerland, is really close to Jersey. And I could definitely see myself driving down New Jersey and seeing houses like this. So there's definitely a lot of potential for it.
Others?
I maybe quickly add that if we were, I mean, this is a private house. If it was a developer, the main argument they would probably have is the wall thickness is so much thicker than maybe a alternative insulated facade. So let's say this one is 50 centimeters, and here in Europe you could build it with 30 centimeters. So like almost half, let's say. And if it would be a big residential building, it would add up to a lot of square feet, square meter, and this is of course how developers would measure it. And then there, you would need to do some convincing why maybe such materiality would be a better, for instance, marketing and so on, in order to compensate for the lost area.
Mm-hmm.
I have a question actually in terms of like the construction and the system. Like here, thinking about like here in New Jersey or you know, just the US overall, I feel like per code, they are so intensive in like fire rating and fire rated stuff. How does this system like comply with like fire rating? Is it easy to be, would it be like in the less I guess in the chart where it's easily, like flammable, or what does it have some resistance?
Yeah. So everything that is in this building would comply with the fire code here in Switzerland. Um, I must say, if you would bring a totally new product to the market, you of course always have to go through testing phase, and those fire tests, along with you have other tests such as structural and so on. They're very expensive. So if you are like a company who wants to bring a new product to the market, it is quite pricey to go through all the steps. And like obviously, I think for the layman, they would often think, well, wood or straw, it's easily inflammable. But there have been tests already done, and like especially in the uh, private sector or like with private clients, this kind of construction is totally working because it's already proved. I guess if it would come to high rises or like big office complexes, um, maybe not, or it's like in a boundary condition, maybe you would need different cladding and so on.
Other questions?
Thank you.
Yeah, could I ask, what, so did you work here in the States or?
Um, no, I did not.
Okay, so what made you like, if you don't mind me asking, what made you go to the Switzerland? Because I think it's really interesting what you're working on, and I like the views and the whole site seemed pretty sick. So I feel like those projects would be pretty kind of fun.
Yeah, so originally I'm from Munich in Germany, which is right like 3 hours drive here from Switzerland, which yeah made me come from Munich to Zurich in the first place. Then I was working in different places. I was also having some working experience in China as an intern. I was working at big firms such as HDM in Basel. Um, but I think Switzerland is kind of well known for having a high building quality, and it was like I don't know, I guess after the master's, um, more or less obvious decision that I think it would be a good place to work here. Also, of course, language is a big topic.
Mhm.
It's German speaking here, at least in this part of Switzerland, and since I come from Germany originally, that's also helpful. Yeah.
Okay, I see.
I can definitely see myself or someone arguing that maybe just the way that the culture approaches building things or the built environment is definitely much different than New York, but just kind of nice to see that people value the craft, people value the material that they use, that they put into their houses. So that alone could be, I guess, like a huge reason why someone would want to move to an area like this. Versus New York, I feel that there's, or maybe just the US at large, there's like a huge emphasis on like building fast, building cheap, and as much as you can. Where these walls, like you said, they're too big for us, right? Like it may not work, but I think there is something nice to, I guess, enjoy and be around people who love the craft, people who actually value buildings and I guess like the places that they sit on.
Yeah, I think it's an interesting point, but I wouldn't make the argument to say like if you want to have that, you need to move to Switzerland. In fact, I would say that um, it's probably there are people in the US who would be able to afford this and would be happy to have it. But I think what is important is to develop culture, meaning you have to communicate it, you need to convince, and most people wouldn't be even aware that it's possible to build with alternative materials. So I think the act of communicating a lot is like very crucial in order to just bring the word out.
I could see this
Good
in New
point.
Jersey. I could definitely see this in New Jersey.
Does anyone have any other final questions, comments, thoughts? Are we all set? Well, Eric, thank you so much. This lecture and topic was very inspiring and, as you saw, very eye-opening for many of us.
Yeah,
Um, yeah, thank you once again for being here. Let's all give him a round of applause. Um, yeah, we'll be in touch, but thank you so much.
yeah, cool. Thank you.
And the rest of you can maybe just stay on for a bit.
See you, everyone. Ciao, ciao.